Question 22. Let u equal root x and then show 2 du is equal to dx over root x. So let's do du dx. Root x is x to the power of a half. So du dx is equal to a half x to the minus a half, which is 1 over 2 by 1 over root x. So du dx has to be equal to 1 over 2 root x. We're asked to show 2 du, so we just need to cross multiply by 2 on both sides. We're going to get 2 du is equal to, multiply both sides by dx, we're going to get dx over root x, which is what we're asked to show. So in this question, if u is equal to root x, we have the cos of u times dx over root x, which is 2 du. So we've replaced everything, so that's the integral of this guy, and if we tidy it up, it's going to be twice the integral of the cos of u du between these two bands here, pi squared over 4 and 0. If we integrate cos, we get sine, so we're going to get twice sine u between pi squared over 4 and 0, and u is equal to root x, so twice the sine of root x. U is root x, so we're going to have the square root of, that's pi squared actually, sorry, pi squared over 4. And then we're going to have, I don't need that bracket, minus the sine of 0, which is 0, so we don't need this, is equal to 0. So we have twice the sine, pi squared over 4 square root, it's going to give pi over 2. Oh, this works out nicely, so twice the sine of 90 is equal to 2 for the first one. In the second one, e to the power of x over root x, we have e root x times dx over root x. Again, it just appears here, it's the same actually in the next one I'm looking, dx over root x. So dx over root x was 2 du, so we have 2 du, if you want to write this one first, and then e to the power of u, and we have the integral of this. I'm deliberately writing in the wrong order, so just to rearrange it, we have twice the integral of e to the power of u du between 1 and 0. So e to the power of u becomes e to the power of u when we integrate it, e to the power of u between 1 and 0 times 2 is going to be twice e to the power of u, which is root x, so that will be the square root of 1 minus, we're going to have e to the power of the square root of 0, which is 0. So we actually have e to the power of 0 and e to the power of 1 twice e to the power of 1 minus e to anything to the power of 0 is equal to 1. So we get 2e minus 2 for this one. And then the third one, we have our dx over root x. So we have 1 over the square root of x plus 2 times dx over root x. This is 2 du. And if u is root x, this one is 1 over u plus 2. And if we tidy this up, we'll have twice the integral of 1 over u plus 2 du. So that's going to give natural logs between 49 and 1. Okay, 49 and 1. So we're going to get twice the natural log of the bottom u plus 2, and that's between 49 and 1. So twice the log of u plus 2, which is the square root of x plus 2, between 49 and 1, just to make it, can't really jump to the answer here, twice ln square root of 49 is 7 plus 2 is 9 minus ln Square root 1 is 1, plus 2 is 3. And that's going to be twice the natural log of 9 over 3, which is twice the natural log of 3, which is the natural log of 3 to be squared, which is equal to natural log of 9.